Okay, this has now been running for about 27 hours and it's been left running at just under 120 volts, which is the voltage this would normally run at, and it looks like it's fine, nothing bad has happened, and the current has stayed fairly consistent. It's just over 0.1 amps, so we're just going to do a final check of the voltage across the capacitors, make sure that they're still within spec. So just under 20 volts and just under 60, which is fine. So that's the voltage we should be seeing on this supply. So what I'm going to do now is put the clamp back onto the PCB, and then I'm going to refit this to the chassis. I won't video that, it's just really a case of dropping it into the chassis, putting the screws in that hold it down, and once we've done that we can actually try printing something and see if the driver can actually drive the solenoid on the printer. Okay, I've fitted the electronics pack back into the machine. I've got it switched to the off position. I've put a piece of scrap paper in. I've refitted the old ribbon, so this is completely dried up, so even if it goes through a print motion it's not going to leave a mark on the paper. I just want to see what it's doing before I replace the ribbon. So we've got the supply switched on, so the next thing to do is to turn into local mode. I've got the power pack plugged into the printer and the keyboard, so it should all be interconnected, and if this is working then when I power it up the motor shouldn't be running continuously, or at least it shouldn't be printing continuously. So we'll power this up. Okay, so the motor's started but it's not printing, so if I press a key now, so this is the first time it's been run for maybe 30 or 40 years, let's see what happens. So okay, well, it's doing something. It's moving the carriage. I'm just trying to see if it's leaving a mark on the paper. It is. Okay, and it appears to be the right character, so okay, what I'm going to do now is replace the ribbon. I'll replace the ribbon and see if we can get any actual printing, but it certainly seems to be going through the motions and it does appear to be printing the right character, so we'll see what it does. Still some adjustments to make on this yet, of course, but it does appear to be getting fairly close to printing. I've replaced the ribbon, so let's give it another go and see what happens this time. Okay, it's printing, but it's not printing the correct characters. I can see why. Some of the encoder bar link levers are sticking up. So that's these levers down here. So we kind of knew some of these were sticky, and that's indeed what's happening. So I can just carry on now and start or continue freeing this up, and once I get all the encoder, all the code bars freed, it will hopefully start printing the correct characters. I also need to tighten the drive belt here, of course it's way too slack. Not surprising, hasn't been run for a very long time, but it is now at least going through a print cycle. It is moving the head, rotating it, raising it, lowering it, advancing the ribbon, so it's doing all the right things. We just need to get the code bars properly freed off. Okay, well you can probably guess from the setup I have here that there are still issues with this machine. I managed to free up all the code bar links. They just needed a bit more lubrication and just really using a bit. But the machine was still doing all sorts of weird things. A lot of it wasn't working. Carriage return wasn't working. It was printing kind of semi-random characters. And normally that's because this timing adjustment's out. but whatever I did with this, it made no difference until if I went to extremes, it just stopped printing completely. But wherever I set this, it wouldn't print properly. And before I really got a chance to look into it too much, the machine came to a sudden stop. And I just thought I'd normally skip through all this, but I've been asked to show more detail of the repairs I carry out. So I just thought I'd go through and explain what I found. I didn't video most of it because there's an awful lot of kind of turning the machine around and poking and probing, so it would just get confusing. So I'll just go over what I found, the repairs that I've done. The most important thing if you're working on one of these and you're not familiar with them is don't start adjusting things, don't loosen screws unless you're very sure what they do. I found a lot of problems with this where certain screws had been loosened off and I think retightened or just left loose, and that was causing a lot of problems. And some of the issues were just adjustments, but most were down to lubrication or just certain linkages and levers being stuck. So I thought I'd go through this. Before we go over that, I was asked about the ribbon. Now normally, this is the old ribbon, normally you have these eyelets close to the end of the ribbon. In fact, this is the end, I haven't cut anything off this. Normally the very end goes onto a barbed connector on the reel, and then about 6 inches from the end you have one of these eyelets, and there's one at each end. Now the reason they're there is to allow the machine to auto reverse the ribbon. So if you imagine this is being fed out of the reel, then when it gets towards the end and the eyelet comes off the reel, it gets to this point, and because there's a narrow slot in this vertical bar, the eyelet can't go through. So what it does is it tends to pull this across and it rocks into the opposite direction of travel for the ribbon. So what this does, this is what auto reverses the ribbon direction, and those little eyelets simply reverse the direction the ribbon's being fed. You can either put the eyelets in, or you can even just tie a knot in the ribbon and it will do the same thing. It will tend to make the ribbon auto reverse at either end. Okay, also I'll just point out at the moment I have a very light impact force set on the print head. It's an adjustment sort of down here, I'll go over that in a future video. I back it right off when I'm working on these machines initially to prevent damaging the print head, so it will print very lightly even with a new ribbon. But later on I'll increase the print pressure until it's printing correctly. Okay, so that's the ribbon. But as I said, the issue I was having before I could do too much was this came to a sudden stop. And if you have worked on these, you'll know that the clutches on them can cause a lot of problems. So I'll just rotate the machine and we'll have a quick look at the clutches before we go into any more of the fault finding that I did. Okay, well hopefully you can see this. This unit here is the function unit. It takes the levers coming from the code bars, that's the long bars that run across the machine at the front, and with certain combinations of code bars then this function unit is triggered. And really it's a series of clutches. So you have these levers that pop up, and these are what are used to select different functions such as the carriage return, ringing the bell, whatever else. But they're actioned through these double acting clutches. So what the clutch consists of is a drum or a disc. There's a spring inside of it, and on the end of that spring is a lever that protrudes beyond the extremities of the drum, and it catches on these levers. So there are two levers. There's this top one, you've got a release lever and then a captive lever. It's I can't really show you too much, it's almost impossible to see because it's hidden by the actual clutch itself. But what happens is when you release the lever, it causes the clutch to engage. So the action of the torque trying to turn the inner part of the clutch compresses the spring inside of it, and if the little tab that sticks out is being held, then it disengages the clutch. But if you release the little tab, the spring can expand, the clutch engages and it starts turning. If you then put the tab back in to the path of the little tab, next time round the little lever that's holding the clutch engaged will hit the tab, it will then the rotation of the shaft causes the clutch to disengage, and as long as you hold that tab, the clutch is disengaged. There are two levers. There is one that's used to engage the clutch, and there's one that's used to hold it effectively in operation. And the two should be mutually exclusive. If they both hit the tab at the same time, then it will lock up the shaft, and that's what's happening, or what was happening here. And all that causes it is, so it's quite hard to see, but on the end of this lever where it rides on the clutch housing, there's a tiny little tab, and if that isn't properly lubricated, then it can't release cleanly, and because it hasn't released, when the other little tab catches the other side of the clutch actuating lever, it effectively tries to drive and disengage the clutch at the same time, and that locks up the shaft. So a bit of lubrication. Also inside the clutch, you can't really see it, but inside the clutch housing there's a little felt pad, and that needs to be kept basically soaked in oil. So you need to rotate it very carefully until you can see the felt pad. Use a syringe or something, inject oil into the pad. You can do it by just putting loads of oil on, but that drips everywhere, makes a real mess, and you end up with a machine that doesn't work because there's too much oil on it. But if you just keep those pads oiled, then the clutches work fine. So once I've done that, the clutches worked, it would then rotate cleanly, and also when you turn it off, you should see it coast down fairly slowly to a stop. If it stops very suddenly or abruptly, then there's too much torque being applied by the motor. And in fact, you should find that, I'm just going to zoom you back out. Okay, if everything's properly adjusted, then you should be able to spin the system around fairly easily. You can see I'm just turning this drive, this is another clutch on the end of the main shaft, and you can see the motor's spinning quite freely. If you can't do that, then there's something wrong somewhere. You won't be able to do this when it's carrying out certain functions such as moving the carriage, but certainly when it's idle like this should spin around freely. If it doesn't, you've got a problem with one of the clutches. Okay, so I'll move the unit back round and we'll start looking at how I started investigating the random printing issue I was having. Okay, so as I said, what was happening was most of the functions weren't working. So although it appeared to be printing, I was getting random characters appearing on the paper. The carriage return wouldn't work, and once I'd got the clutches freed up so I could spin this more freely without danger of damaging anything, I started investigating this. Now, as I said, adjusting the timing control had no real impact, other than if I went too far it would stop working altogether. So I'm pretty sure that's not what the problem was. The next thing to look at, of course, is the operation of the solenoid. Now, I know the solenoid was working. You can actually see it moving when you print a character. It very rapidly moves back and forth, and there are various ways you can address this. It depends on what equipment you have. Now, if you've got a camera that has a high potential frame rate, then what you can do is set a very high frame rate. So my camera will go up to 240 frames a second. You can then video a cycle and then play it back in slow motion. You can see what's going on, and generally you get much more information doing that, because you can see exactly if there's any timing issues or anything sticking. I'll do that later on in the video. I'll video this in slow motion and show you how it looks, and you can see how the clutches work as well. But I have this is a TTI prober, or iProber 520. I will be doing an entire video on this. It's quite an interesting device, and what it amounts to is a specialist current clamp. So in this case I've got it configured as just a wire current clamp, but it has got a tip on it that you can use for probing PCBs and monitoring currents in PCB traces. So I'll do a complete video on that another time. But I'm using it here to look at the current flowing through the solenoid, and this is a good way of testing this. Putting a scope on it is possible, but because the entire supply to the solenoid is floating, it does make it quite difficult. And also, of course this is mains powered, so you do need to be fairly careful with it. But as I say, we're now monitoring the current through the solenoid, and that's what the scope is displaying. So what I'm going to do now is power up the printer, and then I'll press a key, so I'll press the H key, and then we'll capture some data on the scope. So remember, we're looking at the current flowing through the wire going to the solenoid. On the scope we've captured some data, and if we look at the spec sheet, I press the H key. Bear in mind I've had the keyboard completely apart, so this is why I started here. If I'd made a mistake reassembling it, we could be getting nonsense data out of the keyboard. So starting here, if we look at the H key, then the value we should be getting should be 0001, 001, and hopefully you can see the scope. And bear in mind that the solenoid is normally energized all the time when you power up the machine. That's why it always tends to do a full cycle when you first switch it on. So the first thing that happens when you press a key is the solenoid will de-energize. So the first 0, I'll move the camera closer to the scope so you can see it more clearly. Okay, so this is the value we're looking for. The solenoid is normally energized all the time, so the first 0 is really the leading 0, so it's just really the solenoid de-energizing, so you can ignore the first value. The bit rate for this is 10 milliseconds per bit, and I've got the scope set to 20 milliseconds per division, so every half a division is effectively 1 bit. And you can ignore the first half a division, that's just the solenoid turning off for the start bit. The next bit is a 0, followed by a 0. So if we look at this on the spec sheet, so for H we're looking for 0, 0, 0, followed by a 1. And that's what we're getting. So we're getting, let's ignore the first half a division, but then we're getting 1.5 divisions of zeros. And at half a division per bit, that's 3 bits. So that's 3 zeros. The next one we are looking for is a 1, and as you can see we are getting half a division of high, and that's a 1. We then look at the remaining bits, we should get 0, 0, 1, and we are getting 2 or 1 full division of zeros, which is 2 zeros, and then of course the last one is kind of hidden because it's going to go high anyway, but there is a high value, at least it's not a low, and then the solenoid stays on. So we know that the value for the H is correct, so we'll try a different value, different key, and in this case I'm going to press the T. I'm going to press the T. Take it back off so you can hear me. And in this case we're looking for 0010-101. So we start off with 00, and remember the first half of a division is going to be 0 all the time, and then that's followed by a full division of zeros, which is correct. So we're getting 0, 0, then we should have a single 1, half a division of high, which is correct, then a 0 followed by a 1, 0, 1, which is exactly what we're seeing. Now I've tried this with quite a few of the keys, and they were all showing the correct code, so I was fairly confident the keyboard was assembled correctly, the drive electronics is working, and the next thing was, well, is the solenoid actually moving in response to these signals? And there's various ways you can approach this, and again it depends on what equipment you have, so let's move the camera again. Okay, so the solenoid we're talking about is this one here, and this is the actuator for it. It doesn't move very far, it only moves by probably a millimeter, but this is the tip of it here, and that's the bit that you're interested in seeing move. And of course trying to see this move at high speed in real time is extremely difficult, so in a minute we'll try recording at high speed and playing it back in slow motion. But one other thing you can do if you don't have the ability to do that is you can take the fuse out of the motor drives. That's this fuse here. When you then power up the machine, it will enable the solenoid and the drive electronics, but the motor won't be spinning. And what you can then do is press a key and then start manually turning the motor. Obviously be careful, because there will be obviously mains on the fuse holder. And as you turn it, the distributor will turn. And as the distributor gets to each segment, it will operate the solenoid. So what you should see is, for whichever key you press, when you cycle manually through an entire print cycle, then you should see the individual bit values played out as you rotate the motor while the distributor turns, and it's a good way to see if the data coming from the keyboard is correct. Now of course that's not to say it's going to work when you run it at speed, but at least it will tell you if the keyboard is giving the correct codes, and if your distributor seems to be working, and if the keyboard is working. You can also then peer in through this hole here and see if the individual actuator arms are working. So as each cam position is selected, you can see if the appropriate levers are being raised. So as I say, it's not always the same when it's run at speed, but at least it will tell you if fundamentally the machine is capable of carrying out those functions. So okay, what I'll do now is try a different technique. We'll try recording this at high speed, and we'll play it back at normal speed, and that will give us a slow motion view of what's happening in this area while we do a print. So as you can see, that's a fairly good technique to use for something like this. We could clearly see the solenoid plate moving back and forth, we could see the operation of the clutch, and we could even see the link levers moving. And you can do this and video the code bars and anything else and see exactly what's going on. Okay, so I'll just spin the unit around. I'll just go over another fault that it had that took some time to sort out, and that was the carriage return. So the carriage return's a bit of a pain to get working sometimes, and I've had issues with that on almost every one of these that I've worked on. I'll just move the camera down so you can see the basic way that the carriage return works, and then I'll just explain the fault that I found on this particular machine. So the carriage feed and the carriage return work on this ratchet at the bottom end of the carriage feed spool. So with the ratchet engaged and you move the carriage across, you can hear the ratchet controlling the position of the carriage. If you disengage the ratchet, then the carriage will return, and then it will stay in the disengaged mode until the ratchet is reset. So if you reset the ratchet, then it will go back into the positional control mode. And this is normally controlled through a series of links and levers. And of course it's made more complicated because the carriage return can be triggered by various things. So firstly, it can be triggered through the return key on the keyboard. It can be triggered externally, and it all works really the same way in that the function unit on the back, which we'll take a look at in a minute, responds to the code bars, and when the code bars are set for the carriage return code, it triggers a carriage return. It should trigger a carriage return, but it wasn't working on this unit. Also, this lever at the front here, what this is for is as the carriage moves across, then push it all the way across, you get this tab that's attached to the belt travelling this way, and when it hits this, there is a spring-loaded lever that goes down to the bottom end of the basically the ratchet control system, And what it's for is it prevents further feeding of the carriage. So when you get to the end of travel, you don't want it to keep trying to push the carriage further because it would break something. So when you hold this across, it should stop the carriage from advancing. So you can test that quite easily with the motor running. Pull this across, if you press a key, then it should try and print the character, but it should not advance the carriage. The problem I was having was it wouldn't, the carriage return wouldn't work when return was triggered. And if we look down into the bowels of the machine, I'll just move the camera again. So you have these levers running front to back, and there are two basic functions these perform. One is to feed information from the code bars back to the function unit, and the other one is to take values or information from the function unit and feed it forward to the mechanism at the front of the machine. The one we were interested in here was this one, and it's responsible for triggering the carriage return. Now firstly, I noticed that there was no end of travel bell. When you get towards a certain point in the travel of the carriage, the bell should sound, and that was this rear code bar was stuck, so I freed that off, but the carriage return still wasn't working. So if we follow this lever through to the back and we look at the function unit, I'll just briefly explain the way that that should work. Okay, again, this is pretty much impossible to see. It's all covered up by the various parts of the mechanism, but this link here is the one that's responsible for the carriage returning. So this is the function unit, and if I push this down, the carriage should return, which it does. I'll re-engage the ratchet and push the carriage back across. And the way this is supposed to work is there's a lever at the bottom. That's the lever that I was pressing from the front of the machine, and it kind of semi-engages with the bottom end of this link. And what should happen is when that cross lever, the one coming from the front, is pushed down, it should allow this link to move forward, at least the bottom end of this link to move forward. Now underneath this, again out of sight, is a power bell, and it's just basically a bar that rocks up and down through each cycle of the printing, and it's used to provide the force to allow functions to actually fulfill their operations. That's where the actual power comes from. And the way this is supposed to work, there's a small tab at the bottom of this, and when the lever coming from the front is lowered, the bottom of this should move across, and it then inserts that tab that's attached to this lever between the power bell and another lever that goes back to the front of the machine. And if I push down on that lever, again it should cause the carriage to return, which it does. So I'll re-engage the ratchet, push the carriage back across. So the way this is supposed to work is when the code bars select the carriage return value, the lever, the one I was pushing down from the front, is lowered. That allows the bottom end of this link lever to move forward. It inserts the little tab that's attached to this between the power bell and the lever that I just pushed down to return the carriage, and that causes that lever to be pushed down the next time the power bell goes down. So in other words, it's a bit like the way a paper tape punch works. It just inserts a small tab to engage a certain lever with the power bell, and then the movement of the power bell is what causes the carriage to be returned. And what was wrong with this is the bottom end of this lever couldn't move back forward. There was a burr. I think somebody had been poking something down in there, and there was a nasty burr on the slot that it runs in, so the lever wouldn't move forward. So I just cleaned that off. The lever then moves freely, and the whole thing started working. So I'll rotate the machine, we'll power it up, and I'll show you how far it's getting at the moment. So another fault I had with this was the line feed wasn't working correctly. The first time I pressed line feed, it would appear to feed a line of paper, but then when I pressed line feed again, no more paper was fed out, although it did go through the action of trying to process the keystroke. And the way this works is there's a small ratchet system here that's responsible for feeding the paper. And I mentioned in a previous video that these two screws were loose and the plate on the end of this was bent. Not quite sure how that had happened, but it was binding up the platen and it was preventing the ratchet from completing the full stroke when it was trying to feed paper. And then with subsequent line feed attempts, because the pull was not in its start position, it couldn't feed any more paper out. If I manually turn to the next stop, press line feed, it would feed 3/4 of a line again, then it would stop feeding until I reset manually again. That was just caused by it binding up, and one side freed that off and it was able to complete the full stroke of the paper feed. That worked fine. The rest of it is now working pretty much correctly as far as I can tell. I still need to adjust the timing. I haven't got it in its final position yet, but everything else is now starting to work. I've adjusted the belt tension. If I now power this up, although it probably sounds much louder on the video than it actually is, it sounds quite nice. It's quite a nice subdued hum. If I press the key, I'm getting the correct characters. Now and again I get the wrong character. We're actually all printing correctly at the moment, but now and again I get a rogue character, and I think that's just timing. But again, I want to run this for a while before I adjust that, just to let it fully free up and make sure that nothing else is binding up. Okay, the line feed works and also the return works, so everything appears to be working. Turn that back off. Everything appears to be working. I'm getting the correct characters. It's giving us paper feed. The carriage return is working. The here is function is working. Shift works, alt works, control works, and the brake works. So everything appears to be working the way it's supposed to. The ribbon feed is working. So pretty much everything up to this point is functional. I'm going to run it for a while now just to make sure there's no other issues I need to deal with, and then I can move on to the paper tape punch and then finally onto the reader. So that's it for this video. In the next video, assuming that no faults develop, I'll move on to the paper tape punch, see if we can get that working, and we're getting fairly close now to this unit being complete.